In this video, we'll see a thing called power. It's closely related to work. Before we go into it, though, let's ask this question. Would you agree that digging is work? Is this guy doing work? I'm sure you'd say yes. Obviously, he is. He is doing work. But the question is work always done at the same speed? Let's look at an example, examine that. Let's say these two guys are both digging the same hole, same size hole. Which person here would dig that hole faster, do you think? I think it's pretty clear this young, strong guy would do it faster, wouldn't he? Now I'm saying, when I say the same hole, I'm saying it's the same amount of work to dig the hole. But this guy does it faster, doesn't he? So we could say this person in A does the same work in less time. He works faster. That brings us to a new quantity. It's called power. Let's read this. The rate at which work is done, it has a name, is called power. Because work can be done at different rates, can't they? Let's do another example here to explain this a little further. We have a pulley situation here where we have two engines lifting the same weight block the same distance. Okay? Let's ask a few questions about this. First question, how does work compare from A to B? I hope you agree they're the same because it's the same weight object we're lifting the same distance. So both sides, we have the same work. Next question, how does the time compare to do that work from A to B? This is a much more stronger engine, isn't it? Would you expect this engine to lift that object faster than that smaller engine? That would make sense, wouldn't it? So how does the time compare? The time is less for A. In fact, we could say A works faster than B, couldn't we? We could say that. Now, going back to our definition of power, the rate at which work is done is called power. Ask this question. How does power compare from that engine A to that engine B? You're right. Engine A has more power. It works faster. That's what power is, how fast work can be performed. And this object here, probably this engine, can perform that work faster. He has greater power. Going back to our digging of a hole example, let's say each of these persons, or these gentlemen, dig a hole and they do the same amount of work, 300,000 joules of work. This guy here, because he's young and strong, does it in 1 hour, 3,600 seconds. This older gentleman takes an hour and three quarters, 6,300 seconds. Let's do a couple of easy power calculations using this formula here. That's our formula for work. For power. Power is work divided by time. Let me repeat that. Power is work divided by time. So here we go. Simple enough. Work is 300,000. Time here is 3,600. We get 83.33 joules per second. Turns out there's a special name for that, and unit measure is called the watt. 83.33 watts, which abbreviated as W. So this guy's power is 83.33 watts. Over here it's the same calculation, except for the fact that we have more time. So this results in a power of 47.62 watts. Again, the unit measure is the watt for power. So he has a power of 83.33 watts. He has a power of 47.62. This guy here has more power. So power is how fast work is done. He performs the work faster. This older gentleman here performs the same work but slower. He has less power. It takes him longer. He performs the work slower. And that's what power is, how fast work is performed. Grab your video code before we go on. And I have one last thing to tell you about. There are two formulas for power on your formula sheet. This one here and this one here. We're not using this one here. This obviously involves electricity, doesn't it? You've heard about the watts of a light bulb, for instance, the power. You've heard of that before. Sure, that's in this area here, electricity, current, and voltage. Down here we have the one we're using now, aren't we? Work and time. So just be careful. For instance, see, Bill lifts a box 4 meters, 30 seconds. That's obviously this formula here, isn't it? The one we're dealing with. And by the way, the calculation would be this way. First, you got to get your work, force times distance. Do that first, then use it here. Over here, we're using this electricity power formula, aren't we? It's pretty clear what you're going to use in which situation. So just be a little careful. If you're not thinking, you do a power calculation, start using this, and for this one here, you're not going to have an idea what you're doing, are you? You're not going to have I or V. So you need to use that one there. All right, that's it for power. Bye.